Hello, welcome guys. So this question is from the topic Frictional Force and Simple Machine. It says a body of mass 5 kg is projected up a board inclined at about 30 degrees to the horizontal with initial velocity of 6 meters per second. If the frictional force opposing its motion is 4.5 Newton, find the distance it travels before coming to rest and its increase in potential energy at the end of the run. Now first, let's observe what is said. Let's bring out the value. They say the mass of the object is 5 kilograms, right? Then they say it is projected up a board inclined at about 30 degrees. So let's say we draw a board and they say the board is inclined at 30 degrees, right? So there is an object that is projected, right? That object is projected about this point. So there is a force that is trying to push the object up, and there is a frictional force that is acting against the object. Now that frictional force, they say, is 4.5 Newton, right? And then they say the body, right, has an initial velocity of 6. So this body has initial velocity of 6 meters per second. Is that so? So that force that is trying to pull this object up the plane is a vertical force, so it's mg sine theta, right? Horizontal force is mg cos theta. Okay, so let's go back again to the question. We have to bring out some very important things. Now they say a body of mass 5 kg is projected up a board inclined at about 30 degrees, we've done that one, to the horizontal with initial velocity of this, we've gotten that one. If the frictional force opposing its motion is this, we've gotten that one. Find the distance it travels before coming to rest. When a body comes to rest, when a body comes to rest, what happened to it? Its final velocity is equals to 0. Let's not forget that. Its final velocity is equals to 0 meters per second, right? So let's put that in mind. Now, if you observe, they say we should calculate the distance, and distance can be s, right? So which is question mark. Now, look at all the parameters given. They've given us initial velocity, final velocity, they talked about it, and they want us to find the distance. So which of the equation of motion do you think will fit into this problem? From my own deduction, I will say the one with v square is equals to u square plus 2as, right? So judging from this value, we have gotten u already. This is 0 already. We are going to look for this in the calculation. So how do we get acceleration? That's the next pick. Now first, we know that for an inclined plane, right, the force which is trying to pull the object up the plane is going to be mg sine theta plus what? The frictional force, because it has to overcome all those forces, right? So this is the force that it encounters. But this our force, what is the unit for force? The formula for force is what? Mass times acceleration, right? So we're going to be having that plus F, which is the frictional force, FF. So I can call this one FF, right? Frictional force. Okay. So now you observe that from this now we can get what? Acceleration. So let's substitute values and see, right? So our MA is equals to this mass here is given as 5, so we have 5 times g. We already know that g is acceleration due to gravity, so it's 10 meters per second square. unless otherwise stated. So it can also be 9.8 anyways. So we have 10 times sine, what is our theta? 30 degrees. We have 30 degrees, then plus our frictional force, which is 4.5, right? So we have MA is equals to 5 times 10 times sine 30 is 0.5, right? Then plus 4.5. So this is going to give you 50 times 0.5 and plus 4.5. Then when we multiply 50 by 0.5, that's 50 by half, we're going to get 25, right? 25. So 25 plus 4.5 will give us 29.5. Now if we have the force to be what? 29.5. Now let's also note that the mass is 5, right? So MA, so our A is going to give you 29.5 divided by M, which is 29.5 divided by what? 5. So let's divide 29.5 by 5. 29.5 divided by 5. It's going to give you 5.9. 5.9. So this 5.9 is going to be our acceleration in meters per second square, right? Okay, so going back to this our equation now, we can then substitute our values. So our V is 0. Okay, let's put the equation here so that we can follow it gradually. 2as, right? So our V is 0, our U is 6 square plus 2 times A is 5.9 times X. X is what we're looking for. So we're going to be having what here now? Based on this calculation, so we're going to be having, now let's also recall that a body of mass is projected up an inclined plane, right? At about this to the horizontal with initial velocity of the, if the frictional force opposing, so there's going to be a retardation. So whenever there is a retardation, then we're going to be having this acceleration to be negative, because that instead of acceleration it will be retarding. So this A now becomes what? Negative, right? So this A will now finally be what? Minus 5.9 meters per second square. So if we observe that in this question, so we're going to be having minus here, right? Okay, so 0 is equals to 36, plus times minus is going to give us minus. So 2 times 9.5 will give you 11.8, then times S, right? So let's rearrange. So if this leaves to this side, we're going to be having minus 36 is equals to minus 11.8 with S, right? So making S the subject of the formula, S will then be equals to minus 36 divided by minus 11.8. So our distance will be equals to, now let's divide 36 divided by 11.8. Since the minus will cancel through, so we'll be having 3.05 meters. 3.05 meters. So that's the distance they're asking us to look for. Now the last but not the least is to find the increase in potential energy. So the question says find the increase in potential energy, right? So to find the increase in potential energy originally is just mgh, right? But in this case it is in an inclined plane, so the angle of displacement must be what? Recognized. So it will be mg sine theta then times h. Are we good? Yep. Okay, so this is going to give us our m is 5, our g is 10, our theta is 30 times What is our h? Our h is the distance, so it's going to give us 3.05. So the increase in potential energy will be equals to that. So let's do the multiplication. So we're going to be having 5 times 10 times sine 30 is 0.5, right? Times 3.05, correct? Yep. So this is going to give you 50 times 0.5 times 3.05. So we're going to be having 50 times 0.5 is our 25 times 3.05. So the potential energy is going to give us what? So let's say 25 times 3.05. So it's going to give us 76.25. But since this is energy is measured in joules. That's our final answer. So the potential energy will give us what? 76.25 joules. So that's it about this question. Thank you for following from the beginning to the end. I'll see you in the next video. Bye for now.